Okay, let's add some rational expressions here. So add rational expressions. We're going to start with, well, just basic fraction. 1/7 plus 2/7. And you should know this is 3/7. The concept there being quite simple. If I have a pizza or something and I divide it into sevenths, which I'll attempt to approximately put in sevenths here. May not be perfect, but pretend like it is. That's not too bad. If I have 1/7 right here, and over here I have 2/7, and I ask how much pizza did I eat if I ate 1/7 and then follow that up by eating 2/7, well, I ate 3/7. And the reason I can so easily add that is that each piece is the same size. I can quantify it by adding the same sized piece. If I have different sized pieces, I could tell you how many pieces I had, but how much pizza I ate would be harder to say. And we'll worry about that later. But the long story short here, if I have the same denominator, all I have to do is add or subtract the numerators. So let's look at a more complicated example. It's a true rational expression, or more likely rational expression you'll see. Okay, you're probably going to see polynomials with it. So say we have something like this. Okay. So first of all, we have the same denominator, which is great because that takes care of the issue that we would have if we had different size pieces of pizza, so to speak. That's not an issue here. So my job is, just like before in the green example, to simply retain the denominator. I don't have to do anything with it. I just retain it. That means just keep it. So I'm going to do that here. I'm going to write 5x minus 1. And once I establish the denominator, typically we just keep writing it and we just don't worry about it anymore. We just have to realize it's there. So I have 5x minus 1. And just like I added this 1 and this 2 in this separate green problem, the green and blue have nothing to do with each other, but green is used to kind of explain the concepts of the blue. I'm going to combine the two tops together while retaining the bottom. Okay, just like I added 1 and 2 to make 3. Now we do have this minus sign, which we have to watch out for. So when you subtract, I'm going to keep or retain the first term. I'm going to change this minus to a plus, but in so doing, I have to change the signs of everything here. It's as if I distribute a -1, or I just change all the signs. So I'm going to change it to positive 3x squared minus 7x and then plus 1. So notice right here, all the signs have been changed. And that is the reaction to us changing this sign right here. I'll put it in green. That negative became that positive. And whether you want to put parentheses around these or not are up to you. They're not really necessary here because the fractions separate them anyway. But this stayed the same, but all these changed. Now, had this been a plus, they would have both been the same. Okay. One more line. Again, we're generally content with our denominator once we establish it to be the same on both of them. So I haven't done anything to 5x minus 1. I'm just going to combine like terms as you've done in a past lesson. So x squared plus 3x squared, that's 4x squared. Okay, negative 4x minus 7x is negative 11x. 2 and 1, that's 3. Okay, and as complicated as the answer looks, that's it. And in the next video lesson, we'll look at what to do when you have different denominators.